So welcome to the fourth class of our computer architecture and organization. So in this class, we are going to discuss about the history of a computer. Okay, I think you all are familiar with this topic, but as it is in the syllabus, we are going to discuss this concept once again. Okay, so in this class, we are going to discuss about the history of a computer. That means when the computer was invented, how it was invented, what are the different types of computers, or what are the different generations of a computers. That is the topic what we are going to discuss now. Okay, here if you first of all, the computer, as you all know that Charles Babbage is the father of a computer. You all are familiar with that now. So here the computer generation here the initial computer is first generation computers. So what is meant by first generation computers, or what are the major components that are used in the first generation computer? In the first generation computers, they have used vacuum tubes. So vacuum tubes were used as a main components or main elements, or simply to say the main functions that are to be performed by a processor are going to be performed by these vacuum tubes. So in the first generation, they have used vacuum tubes, and the architecture is von Neumann architecture. See, this is the thing you have to know, because every one of you, or most of you, know that the generations of a computer. First generation vacuum tubes were used. Second generation transistors. Third generation small scale integrated. Fourth very medium scale, large scale, very large scale. Like that, you all are familiar, isn't it? But there is no need of explaining once again. But along with this concept, you have to gain the knowledge on other topics also. Here, if you observe this slide, okay, you all know that I do know very well, because since from our 5th class, we know about the computers and its generations. Okay, here also the main concept is not the first point. You all know that in a first generation vacuum tubes were used, but my main concept is to make you aware of about the second what do you call it? Yeah, here the second point, what here they have mentioned, von Neumann architecture. The main concept is, or the main thing what I want to present to you is what is meant by von Neumann architecture. Okay, that is my intention, because you all know that in first generation vacuum tubes were used. Okay, along with this, what is the third point I was mentioned here? Basic arithmetical operations will be performed. That means in first generation computers, it is going to perform only the basic operations. That means only arithmetical and logical operations are being performed by using the first generation computers. And in this first generation, they have used vacuum tubes. They have used vacuum tubes. And this is the third thing I have to explain you much more. That means here von Neumann architecture is being used. So what is meant by von Neumann architecture? What we are having two different architectures. One is von Neumann or Princeton architecture, and the second one is Harvard architecture. What is the difference between these two? Now that I will explain. Okay. So this is the first slide. So for the first generation, we have used the vacuum tubes. Okay. So this is the overview of a first generation computer. Okay. So the first generation computers exist from 1940 to 1956. So this is an array where we have used, or we have developed the computers by using the vacuum tubes. Okay. So if you observe the size of this particular computer, this is the screen, this is the monitor. You can see here there is a person sitting and he is seeing the screen. So this is the size of the monitor that is used in the first generation. Okay, and this is the CPU and all this, what we call background. This is the background. That means here you can see interconnection of multiple number of bytes. Those are nothing but buses, and these are the backgrounds. That means this is the front end and this is the back end image. If you observe here, the CPU is not this much size. Here, this is the entire components come under the, whatever the components that are present, these are all come under the components of a CPU. Okay, that means it is of very big size, because The main component what we have used in the first generation are vacuum tubes. So obviously the size of the computer is obvious, it is occupying a entire room. You can see this is the front part, and here the components all are related to this particular computer, and the storage capacity of this particular first generation computers are also very less, not even 1 MB or 2 MB. Okay, so very less storage capability, size is very big. They have used vacuum tubes. This you all are very much familiar. But what is the new thing you and the first generation computers, they are used only to perform the basic operations, basic arithmetical operations, in the sense. Now, what are the operations you can perform by using a normal calculator, not a scientific calculator, but a normal calculator. If you purchase any 50 rupees calculator in China, in a Sunday market or somewhere, by using that calculator, you can perform some basic operations, performing a square root or adding a two numbers or doing some additions and subtractions. Those operations are only being performed by this first generation computers. Is it clear? So the era is from 1940 to 1956. Okay, next. See, this is what we want to learn now, because this is a very important concept. It will come in your microprocessor and in your final year embedded systems. And if you opt embedded systems as an elective, or if you go for your MTech, or if you want to go for any embedded system side, then you should be familiar about these architectures. There are two basic important architectures that are present. First one is von Neumann architecture. The other name for this von Neumann architecture is Princeton architecture, and the other one is Harvard architecture. So we are having von Neumann architecture and Harvard architecture. Okay, what is the basic difference between these two? See, initially, that means first generation computers all use this von Neumann architecture. Simply saying, it is a complex architecture, because as we are very much familiar from the previous classes that the memory has to store the program as well as data. మనం మెమరీలో ప్రోగ్రామ్ స్టోర్ చేసుకోవాలా, డేటాను స్టోర్ చేసుకోవాలి, అవునా కదా? ఇక్కడ వాన్ న్యూమన్, హార్వర్డ్ అని రెండు ఆర్కిటెక్చర్ ఉంటాయి. ఇది నెక్స్ట్ సెమ్ లో మైక్రో ప్రాసెసర్ లో వచ్చింది, తర్వాత ఎంబెడెడ్ సిస్టమ్స్ లో వచ్చింది. ఇది నేను స్పెసిఫిక్ ఎందుకు చెప్తున్నానంటే, వాన్ న్యూమన్ ఆర్కిటెక్చర్ అంటే ఏంటంటే, మనకి కామన్ మెమరీ లొకేషనే ఉంటుంది. ఆ మెమరీ లొకేషన్ లోనే నువ్వు ప్రోగ్రామ్ ని స్టోర్ చేసుకుంటావు, డేటాని కూడా స్టోర్ చేసుకుంటావు. ఓకే, అంతేగాని దానికి ఒక సెపరేట్ మెమరీ, దీనికి ఒక సెపరేట్ మెమరీ అనేది ఏమి ఉండదు. ఓకేనా? ప్రోగ్రామ్ వచ్చింది, తీసుకుపోయి మెమరీలో పడేస్తాం. డేటా స్టోర్ చేసుకోవాలి, దాన్ని కూడా తీసుకొచ్చి నెక్స్ట్ మెమరీ లొకేషన్ ఎక్కడ ఖాళీ ఉందో అక్కడ పెడతాం. అంతేగాని దీన్ని సెపరేట్ గా ఇక్కడ స్టోర్ చేసుకుందాం, దీన్ని సెపరేట్ గా ఇక్కడ పెట్టుకుందాం అని ఉండదు. నెక్స్ట్, రెండింటికి కామన్ బస్లే ఉంటాయి. ప్రోగ్రామ్ మెమరీకి, డేటా మెమరీకి కామన్ బస్లే ఉంటాయి. బస్సులు అంటే మనం ఆల్రెడీ లాస్ట్ క్లాస్ లో మాట్లాడుకున్నాం. Buses are nothing but group of bytes. Group of bytes are referred as buses. Here, if you observe this von Neumann architecture, there are no separate address buses and data buses, or there are no separate allocation or separate buses for program and data. Here, the common buses are being used for both the things. If you go for Harvard architecture analysis is there are separate program memory location and separate data memory location. Program memory location separate ga untadi, data memory location separate ga untadi. Program data memory location only program ne store cheskuntam, data memory location only data ne store cheskuntam. So దీని వల్ల ఏమైంది అంటే హార్వర్డ్ ఆర్కిటెక్చర్ అనేది చాలా బెస్ట్. ఎందుకంటే అమ్మా, డేటాని స్టోర్ చేసుకోవడం ఈజీ, and retrieving of the data is also easy when they are stored separately. The best example, if in your home, if you are having a rack, with rack undi or shelves ఉన్నాయి, partitions ఉన్నాయి, దానిలో మీరు ఏ బుక్స్ విడివిడిగా స్టోర్ చేసుకున్నారు అనుకోండి, చాలా ఈజీగా ఉంటుందిగా. లేదు, ఇంకా జనరల్ ఎగ్జాంపుల్, if you consider your computer, I think most of you have a PC or a laptop. In that you are having different folders: C drive, C drive, D drive, E drive, F drive. Okay. So what is the main purpose of having 4 drives means you can easily store different types of data in different types of drives. That means you can the C drive is entirely for softwares. You can rename the D drive as educational drive, and you can store all these educational videos or educational books, whatever the educational material that is related to your education in that particular D drive, and you can rename as the E drive as some other drive. That means what you call a general drive, where you can store the small jokes or small video comedy videos that will be downloaded from your Facebook or WhatsApp, whatever it may be, that you can press. And F drive you can rename it as what we call a movie drive, movies, and you can store all the latest movies. So what is the purpose of partitioning the memory, or what is the purpose of having separate memories means whenever you want to search for a particular movie, obviously did you go to the C drive and did you search? No, isn't it? You automatically you go to F drive, where you rename it as movies drive, and you just search in the F drive the required movie what you want. So what is the advantage here? The process of searching becomes simple, both to you as well as to the computer, because there are separate memory locations for separate data. C drive is only allocated for software storing, and D drive is used for educational purpose. That means whatever you want some material regarding to CAO, then obviously you don't go to F drive. You will search in the D drive so that you can get the required material. So what is the thing? What is the advantage? Obviously, searching becomes very simple to you as well as the computer. So you can get the required task in a less time. That is the main advantage of this one. Where that is present in Harvard architecture, where there is a separate program memory and separate data memory. But in the initial computers, we are having one NEUMAN architecture. Here there is no separate memory partitions. We are having a common memory where both program as well as data are going to be stored. Okay, that too they are not stored differently. If, for example, if there is any data, it will store in the first 10 memory locations. And whenever a program comes, automatically it is going to be stored from the 11th memory location itself. Afterwards, if any data comes, it will store in the next memory location of the program. Like this, the process is going to be taken place. Okay, so that is von Neumann architecture. The other name for von Neumann architecture is Princeton architecture. So once again, we will go through the points that are present in this slide. Okay, this is very important for your microprocessor MPMC point of view, as well as embedded systems in 4.1 point of view, as well as if you go to any embedded system courses after BTech, or if you want to take any MTech, the specialization of embedded systems, then these things should be familiar. These are the basic interview questions one can ask in our code. What is the difference between von Neumann and Harvard architecture? And what is the difference between disk and sys that we are going to discuss in the next slides? Okay. Okay. So here, see, data and instructions. Instructions means set of instructions is nothing but program. Okay. Don't think I have told some wrong information or I have communicated some wrong information. What I have told, both the program memory and data memory are present in a single, both are stored, both the program and data are stored in a common memory location. Here instead of data they have given instructions. Program is nothing but set of instructions. So don't what do you call mistake me. Okay. So here von Neumann architecture means data and instructions are stored in a single read-write memory. Read-writable memory means it is RAM, random access memory, not ROM, read-only memory. Okay, na? It is a RAM, so where you can store and retrieve whenever there is a required. Okay, na? This consists of the memory or addressable by location. Execution occurs in a sequential fashion from one instruction to the next. Here you can see this one. Here execution will occur one by one because there are no separate lines or separate buses for program and data. both the program and data are stored in a common memory location, and there is only a common bus for accessing both the program as well as memory. There are no separate buses. So here the execution will take place from starting memory location to the down memory location one by one. That means first it is going to execute the data or program whatever that is present in the first memory location, later on second memory, later on third memory, like that. Whether it is program or data, it is going to be executed in a sequential manner in this von Neumann architecture. Okay, but if you consider any Harvard architecture, there are separate address lines for program and data, so that there will be a parallel execution, because there is a separate line for program memory and there is a separate line for data memory. Okay, so program and data memories are going to be exchanged independent of each other, whereas in von Neumann architecture there is no such facility. Okay, here both the program and data are going to be stored in a single memory location, so they are going to be executed sequentially depending upon the position they were placed in the memory location. Okay, see, don't think why I am giving this much explanation. This is very important topic till your final year, and if you take any embedded system course, these are the basic questions that they used to ask. Okay, okay, I'm moving to the next slide. Okay, so that is the end of the first generation. So what is the duration of the first generation? Sorry. So what is the duration of the first generation? It is from 1940 to 1956. Here in the first generation, vacuum tubes were used. So the size of the system is, so you can see in the images now, the size of the computer is almost the size of a big room, which is approximately equal to a classroom. Okay. Next, we are moving to the main architecture that is used in the first generation is von Neumann architecture. Von Neumann architecture were used in the first generation computers. Okay. Next. So now we are going to discuss about the second generation. See, as you all are familiar, the transistors were invented. So as you all are from the ECE background, you should be aware who invented the transistor, what is meant by transistor, because you have come across EC subject and ECA subject. So what is meant by transistor? Transistor, transfer of resistance, trans plus resistance is a combination of two terms. Transfer of resistance. Okay, so it is a three-terminal device. There are different types of transistors like BJT, bipolar junction transistor, whatever it may be. So in the second generation, instead of vacuum tubes, the vacuum tubes were replaced with transistors. The vacuum tubes were replaced by transistors. So that is the thing that they have done in the second generation. So whenever we replace the vacuum tubes with the transistor, obviously the size of the system becomes to half. That means previously it has occupied the size of one big classroom. Now it is going to occupy only half of the classroom. So with this invention of this particular transistor, obviously the size of this particular computer has become half. Okay. Along with these transistors, they have made some advancements in the particular second generation computers compared to the first generation. What are the advancements they have done is magnetic core memory, magnetic drum storage devices were used. So in the second generation, they have used some storage devices. They are secondary storage devices. Okay, secondary means external storage devices. So what are they? Magnetic core memory and magnetic drum storage devices were used in the second generation computers in order to store the data. And see, I think you all are much familiar with this name, Fortran, F-O-R-T-A-N. Fortran is one of the computer language. Okay, this particular computer language, Fortran, was developed. Okay, and it was executed successfully in second generation computers. Okay, so the Fortran language was being developed and it was executed successfully in second generation. That means in second generation we have used the high level languages. Next, here along with this, what is the one more facility is separate IO process which works in parallel with the process were developed to enhance the speed and performance. What is meant by separate IO process? IO means input output process. Okay. What is meant by separate IO process means, for this thing I have to give you a best example. See, before 1980s, if you want to do anything, that means either if you want to go for any registrations of your land or marriage registrations, whatever it may be, there won't be any what you will call and then you have to go to only the district headquarters, Tahsildar office. Okay. In 1980s or before 1980s, if you want to do any registration, whether it is a land registration, marriage registration, or whatever the death certificate, in order to get any birth certificate, whatever it may be, for everything you need to approach the district headquarters. That means if I am in Tenali, I belongs to Guntur district, then I have to what you call approach the Guntur district headquarters, Tahsildar office. Then I have to apply and I have to get it. Okay, so then obviously there will be a huge rush because for entire district if there is only one office, obviously the rush will be very much. So there will be a lot of delay, and I have to, as I am not a local person, I don't know what to do and how to do. So it is a very big burden to me. So after that, there are due to some amendments, they have given or sanctioned the Tahsildar office. They have sanctioned or given the rights to each and every what you will call Mandal headquarters Tahsildar offices to issue the birth certificate, death certificate, what you will call land registration were being issued. That means after during the term of 1990s or so there is these amendments taken place where a particular person born in Tenali can get his birth certificate in Tenali itself, because the headquarters of Tenali Mandal is Tenali. Okay, so the persons who belongs to this Tenali Mandal, they need not go to the district headquarters of Guntur. They can get it from the Tenali itself. So if you observe here, automatically the burden on the persons in the Guntur headquarters, Guntur Tahsildar office is reduced to a lot, because for every mandal there is a Tahsildar office where the local people are going there and getting. And if you observe there, now the particular government they introduced a Grama Sachivalayam, okay, where you can get your birth certificate or whatever the certificate, and they are planning even to do the registrations, land registrations, marriage registrations. You can get marriage certificate, everything in the Grama Sachivalayam itself. So now the person in a particular what you call colony, he need not go to an he need not move from out of this colony. He can get whatever the requirement certificates, or if you want to do any registration of his land, if you want to buy or sell any land, he need not approach the mandal headquarters also. He can just do these operations in the Grama Sachivalayam, or what we call secretariat that is present in his street itself. So he can walk there and do the work within no time. And at that particular time, there won't be any bother. You need not take the help of any mediator or something. You know everything, and you know that particular person, and that particular office is in your what we call own area only. So that is the advantage. Here also the same thing is going to happen. Here we are having what we are having separate IO process. So as along with the main process, we are having a separate IO process. So the main purpose of this separate IO process is they will do their work simultaneously along with the main process, so that the burden on the main process is going to be reduced to a great extent. Just like what I have told before 1990s, before 1985s or something, before NDR or something, there will be only For entire district, there will be only district Tahsildar office where everyone belongs to that particular district has to approach in order to get their birth certificate or death certificate or any land registrations or whatever it may be. But afterwards, they have what you call they made the burden less on that particular district headquarters, and they have given the permissions or what we call authority to the mandal headquarters to do the tasks. Now, in this government, they have given the authority to even the Grama Sachivalayam or Ward Sachivalayams to do the task. So, the burden on even the mandal headquarters is going to be reduced, or mandal Tahsildar office is going to be reduced to a great extent. So that is the main concept here also. We are having different parallel IOs. So they are going to perform the task individually so that the overall task and the cost is going to be reduced by a great extent. Okay, this is just for your reference what I have given the example. Okay, don't think much more regarding it. Okay. So this is one type of transistor, not your BJT, I think not your BJT, but this is one type of transistor. So as I have told that transistor is a 3-terminal device. Here you can see 3 terminals. Okay. So the second generation is from 1956 to 1963. So in this second generation, they have used the transistors. So you can see the image of the second generation computer. So obviously, just fitted. It is just like what you will call our setup in our EDC lab. So in our EDC lab, we are having one setup, CRO, function generator, RPS, regulated power supply. Like that, there will be a table with all these arrangements. So in the second generation, the computer, to some extent, it looks like just like something more, not equivalent to our EDC lab table, but somewhat equal to the entire equipment was being placed in a big table. So from a size of one room, it has just reduced its size to a big table. Okay, so this is the second generation computers. The second generation is from 1956 to 1963. In second generation, what is the main achievements? They have used the transistors, so the size is reduced to a great extent. Next, here they have developed high-level languages. High-level languages are nothing but photons, and there are parallel I/O. There are parallel I/O. Okay, so that is about the second generation. Next, now we are going to the third generation. Okay, here what are the main features of third generation? So in first generation, transistors were used. Second generation, first generation, vacuum tubes were used. In the second generation, transistors were used. Now we have moved to the third generation. Okay, here what are the advantages of third generation? First one is lower cost. Here what are the components we have used is we have developed the IC technology. What is meant by IC? The full form of IC is integrated circuit. Actually, more than me, you are much more familiar about this IC because in this semester you are having DICA and LICA. Okay, so in both IC is same linear integrated circuits, digital integrated circuit analysis. Isn't it or not? So what is meant by an IC? An integrated circuit is the combination of active elements and passive elements. They are fabricated on a single silicon chip. That is the definition of an integrated circuit. Is it the large number of active and passive components fabricated on a single silicon chip is referred to as what we call an IC. That means in the second generation you have seen transistors, na? So here we are having a transistor. See, in third generation we are having an IC where hundreds or 10 to 100 of these transistors are being placed in a single silicon chip. The silicon chip size will be somewhat bigger than this particular transistor. That means it will be approximately size of the area occupied by 3 to 4 transistors. But in that particular IC, some hundreds of transistors are being fabricated, or 50 to 100 transistors are being fabricated. in that particular IC. So that technology will be referred as SSI, small scale integrated circuit. Okay. So here in the third generation they have used small scale ICs. So this is the small scale IC. Here you can see these kind of ICs. You will see in the LICA and DICA also. And practically in the LICA lab or in the LICA in the first unit itself, IC 741 operational amplifier, like that. In the topics you will come across these kind of ICs. Okay. So integrated circuit means large number of active and passive elements like transistors, diodes, capacitors, resistors. These are nothing but some are active elements and passive elements. They are fabricated on a silicon chip. That means in the ECL, okay, you have done different experiments in EDC or ECA. Okay, in EDC lab you made an CE amplifier, CD, CC amplifier, like that. So for doing that particular doing CE amplifier experiment, you need one BJT, some transistors, some capacitors, all these things, and you need some connecting wires. So it takes almost half to 3/4 of a breadboard in order to do that particular connection, isn't it? But whenever there is a, instead of that, you can do the entire task. That means instead of using those particular transistor, capacitors, resistors, all these things, stop using all these things, you can do the particular CE amplifier, or you can get the particular CE amplifier output by using a single IC, by using these kind of single ICs. Okay, so that is the main advantage of this integrated circuits. Here there is no complexity, everything was inbuilt, you need not bother, because the company before releasing it to the market, they will take care of its performance and everything. Okay, so the person just he has to bring it and he has to fix it wherever he is required. Okay, so that is the main advantage of this third generation. Here in third generation, the IC technology was started. So in the third generation, they have used SSI, small scale integrated circuits. The integrated circuit, the definition of integrated circuit is large number of active elements and passive elements are fabricated on a single silicon chip. Large number of active and passive elements are fabricated on a single silicon chip. So what is the purpose of this one means, instead of doing a using connecting wires, using resistors, capacitors, transistors in order to do a particular experiment, instead of doing all these things in a breadboard where it used to occupy a lot of place, isn't it or not? So if you want to do any CE amplifier or CD amplifier or CE characteristics, isn't it or not? If you want to do any experiment, you need to connect some 8 to 9 components, one transistor, at least 4 resistors, one, 2, 3 capacitors. Okay, like that you need to give. So it obviously some should be connected in series, some should be connected in parallel, like that. Okay, if you want to do any RC phase shift oscillator experiment, then obviously, so if you want to do any RC phase shift oscillator, then obviously it will take much more place, isn't it or not? So that particular RC phase shift oscillator can be implemented by using a single IC. That will be this much shape. It has some 10 pins or 8 pins like that. Okay. So obviously it will reduce the size. Next, obviously it will reduce the power consumption and all these things. So in third generation, we have used small scale integrated ICs, small scale ICs. So more transistors are fabricated on a single chip. That's what I have told. Okay. Instead of using in order to design a circuit, if you want 10 transistors, 10 capacitors, 20 resistors, all those things will be fabricated on a single silicon chip with the size that is showed in the next slide. Okay, so with this much size of an IC, you can fabricate 10 resistors, 10 capacitors, 20 transistors, and everything. Okay, so obviously this will result in the reduction of the power consumption. Occupying space is going to be reduced, complexity is going to be reduced, because you are nowhere bothered about its features, you are nowhere bothered about its connection. The person who sold you, he will take care of all those things. Your main purpose is to just connect a particular thing to a particular terminal. Okay, so that is the one more advantage. Next, Here, see, these are the things you have to know. Micro programming, parallelism, pipelining. This is what I will explain in the next slides. Micro programming is present, parallelism is present, and pipelining. Parallelism means, as we have told previously, the second generation itself. So here we are having so many co-process. So with the help of co-process, we are going to do the task simultaneously. That means one co-process will do the one task, other will do the other task, and some other will do the other task. So parallelly, we are going to perform multiple number of tasks. This phenomenon is called parallelism. Okay, and cache and virtual memories were developed. So what is meant by cache-free memory and what is meant by virtual memory? Now we will discuss in the next slides. Okay. What is the time? Yeah. I will move to the next slide. Okay, so this is the third generation computer. You can see here the equipment has a less monitor size is being reduced to a great extent, and the keyboard we are having here, keyboard facility. Along with this, there are see this big stand or whatever that is indicating by my pointer. Here there are different types of pies and different types of components. So that means here there is a bulkiness you can see, because we have used only small scale integrated circuits. So still requires many number of ICs, because one small scale IC can replace only 50 to 100 components, not much more. So the size is reduced, but not to a great extent. Okay. Next we will move to the fourth C. Here, as we have discussed, in the third generation we are having special features. What are the special features? Micro programming, parallelism, and pipelining. Now we are going to discuss what is meant by pipelining. See, this is also very important topic, pipelining. What is meant by pipelining? Before going to the pipelining, what we need to know is, see, first of all, what is meant by program? Program means group of instructions. Is it or not? Okay, I think I will stop here and I will start from the next slide. Okay. I will stop here and I will